In this video, we're going to look at calculating pressure using the basic definition of pressure. So in this question, we've got a penny, so that's what's represented over here in blue. I realize that it is a terrible drawing. Anyway, so that's supposed to be Abe Lincoln there on the surface of the penny. So we want to know what pressure does a penny exert if it's resting on the palm of your hand, right? So you can feel the weight of a penny if you were to put it on the palm of your hand, and that's because the penny is exerting a downward pressure, and we want to know what that pressure is. So in order to calculate this, we're going to go back to our original definition, right, which says that pressure is equal to the force divided by the area. So the penny has some mass, and gravity is going to be pulling that down, and so it's going to be exerting a pressure on the palm of your hand, and of course the penny is going to have some area. And we're going to imagine that the penny is resting down on its flat surface rather than on its edge. So there's some area associated with this penny. So if we know what that area is, and we know what the force is, then we can just plug them into this formula to calculate that. So right now we don't know what either of those two things are, so we're going to have to figure out some ways of calculating those. So first off, F, force. How do we calculate force? Well, you have to go ask Sir Isaac Newton how to do that, and Sir Isaac Newton will tell you that force of an object is equal to its mass times the acceleration on that object. So if you know the mass and you know the acceleration, you can calculate force. So in this case, we need to know the mass of the penny, right? And we also need to multiply that by the acceleration. So it's being accelerated downwards due to gravity. So G is used as the gravitational acceleration symbol, and that's a property of gravity here on Earth, and that can be measured, and it's a constant. So we can plug in the value of that constant and then calculate what force is. The other bit that we're going to need is to calculate area. So the surface area of this side of the penny, well, that's a circle. So we know that the area of a circle is pi times r squared, where r is the radius. So that's a formula from geometry. Pi r squared. No, pi r round. No, pi r squared. Okay, haha, yeah. So pi times the radius squared. So then we just need to go about measuring these two properties, the mass and the radius, for a penny. So it turns out that look up a value for g. So let me give you what some of those values are here for our penny. So g, so this is not specific to a penny, is equal to 9.81 meters per second, or meters per second squared. So that's the acceleration due to gravity. So you will increase every second your speed by 9.81 meters per second as you are falling. That's what that means. All right, so now the mass of the penny. So we stick a penny on a balance. Turns out a penny weighs about 3 grams. Now in our calculation of pressure, we need to think about our units. So probably we're going to want to calculate pressure in its SI unit of pascals. So we're going to use the Pascal. So that means that all of these quantities over here, force and area, need to be in their SI units. So what we're going to do to make sure that happens is at the outset we're going to convert all of our units into SI units. So is gram the SI unit for mass? No, it is not. So the kilogram is the SI unit of mass. So we need to convert. So there are 1,000 grams in a kilogram. So 3 grams is a small number of kilograms. So we're dividing this number by 1,000. So that means we're going to move this decimal place that we imagine is right here next to the 3 over 3 places. And so we're going to get 0.003 kilograms as the SI unit for the mass of the penny. Now we grab our rulers and we measure the radius of a penny. So the radius of a penny works out to be about 0.75 centimeters when you measure it. Now again, we want to think about SI units. So is the centimeter the SI unit? No, the meter is the SI unit for length. And so we want to take this number, and we realize that there are 100 centimeters in every 1 meter. So we're going to divide this number by 100, and we get 0.0075 meters. So now we have all of this data. We have R, we have mass, and then we have our equations. So now it's time to put all this together into the calculation. So I'm going to scroll down a little bit so we have some room to do that. Leave all our numbers up where we can see them. And now let's do our calculation. So pressure equals force. And what is force? Force is mass times the acceleration due to gravity. And then we're going to divide that by the area. And what is area? It's pi times r squared. Calculate the area. So now we're just going to plug in our numbers. We've got 0.003 kilograms times the acceleration due to gravity, 9.81 meters per second, divided by pi, and r, 0.0075 meters, and that gets squared. So now we're just going to punch this into our calculator very carefully, and you'll see that we have some of our units are going to still be there when we're all done. So we're going to have units that look like kilograms. And then up here we have a meters, but we have a meter squared down here, so that's going to give us a meter in the denominator. Well, it turns out that this kilogram meter per second squared up here, that's the same as a Newton, which is force, and then per unit area gives us the unit of pressure. So you'll just have to take my word for it that when we multiply all these units together, that combination of units turns out to be the thing that we call a Pascal. Anyway, so let's write this down. So we're going to do our calculation, and it works out to be, when we're all done, 170 is the number that you get when you multiply and divide and square and do all the stuff, including your pi. And then we'll have all these collection of units, but that collection of units, because these are SI units, is the SI unit for pressure, or the Pascal. So, one single penny sitting on your palm of your hand exerts 170 pascals of pressure on your hand. If you have 2 pennies, you'll have twice that much pressure on your hand, stacked up, that is. Okay, so that's how we go about an example of how we go about calculating pressure.